So the second unit in grade 9 advanced science has the title Characteristic Properties. We've already begun doing some experiments on freezing point and melting point. In our first few experiments, we looked at the cooling curves of naphthalene, and you've done an assignment looking at the cooling curve of para-dichlorobenzene, PDB. You've looked at a cooling curve of lauric acid as well. We know that we can get the freezing points from those cooling curves. We've also done heating curves. We looked at the heating curve of methanol, for example. We did an experiment to measure the boiling point of methanol, and we created a heating curve for that. In those experiments, we were using relatively large samples of the chemicals. So a test tube that was half full of naphthalene, for example, or a flask that held 30 or 40 milliliters of methanol. In our next experiments, the ones we're doing right now, we're looking at very, very small samples of substances. So you did a micro melting point experiment where you determined the melting point of a tiny sample that fit in a capillary tube of naphthalene, of BHT, and of lauric acid. And we're also going to be doing micro boiling point experiments where we measure boiling points of liquids, but only using tiny, tiny samples of the liquids. You couldn't ever do a heating curve with such a small sample. Characteristic properties are properties that are used to identify unknown substances. In those first few experiments, we were looking at some very common examples of characteristic properties, freezing or melting points, and boiling points. But there's another part to the definition of characteristic properties. To be a characteristic property, it's not just enough to help identify a substance. The property must be the same no matter how big of a sample you're studying. So the characteristic properties value, for example, would be the same value whether you were measuring the freezing point of a large sample of liquid or measuring the melting point of a tiny, tiny, tiny sample of the solid substance, remembering that a freezing point and a melting point are the same temperatures, right? So the size of the sample does not matter in a characteristic property. It's a property that could be used to identify a substance, but the size of the sample doesn't matter. Common examples beyond the melting and freezing points, boiling points, we're also going to be looking at density, a very common characteristic property as well. Just as an example here, you've got a data table, you've got an unknown liquid you're trying to identify, and you've measured the mass of the sample, you've measured the volume of the sample. Think about that for a moment. If I told you that I have 22.54 grams of an unknown liquid, and then I said, guess what liquid it is, you would laugh at me, right? Because any liquid could have that mass. Knowing the mass does not help identify the substance, so mass is definitely not a characteristic property. If I told you the volume of the sample was 22.3 milliliters, well, by itself, the volume is also not a characteristic property. It doesn't help identify the substance. I detected the odor and said it's odorless. I looked at the color and said it's colorless. Well, those are nice things to observe, and they can help provide evidence to identify something, but those are not characteristic properties either. The odor might be a little bit different with a tiny, tiny sample versus a large sample, and similarly the color may not be the same either. So those are not characteristic properties. Now, if you took that mass and that volume and you combined them to calculate the density, and then I said to you that the unknown liquid that I have has a density of 1.01 grams per milliliter. Well, somebody who knows something about density might say to themselves, I have a liquid that's colorless and odorless, but its density is very close to 1. Well, you're probably thinking, water has a density pretty close to 1 gram per milliliter, so maybe this is water. So you're already trying to identify the substance based on its density. Now, one characteristic property by itself is not conclusively able to identify a substance. There may be several different colorless, odorless liquids that have a density pretty close to 1. So density by itself wouldn't let you conclusively determine that you have water. But then you take that liquid and you also measure its freezing point. And in your experiment, you get 0.2 degrees Celsius. Well, that's very, very close to the freezing point of water, which is 0 degrees Celsius. So now we have two characteristic properties, the density and the freezing point, that are both pointing at water. We're pretty confident that we have water now. But we do a third characteristic property. We look at the boiling point of the liquid. And now we see it boils at 99.1 degrees Celsius. Well, we were pretty confident a minute ago that we're probably looking at water. At this point, with a third characteristic property, we can conclusively say that this liquid is water, right? With those three characteristic properties together, there won't be another liquid that has the same density, the same freezing point, and the same boiling point as this. So this is water that we have, right? So characteristic properties, they are used to identify unknown substances, but they don't depend on the amount of substance being studied. On the back of your solubility chart for grade 9 advanced science, this is found in your data booklets near the back of the booklet right before the exam checklists for the different units, you have a data table like this, a data table of different characteristic properties. So at the top of the page is a table of densities for different solids, different liquids, and different gases. Notice that the gas densities are very, very small compared to liquid and solid densities. And below that, you have another data table of melting points and boiling points for various substances. And again, melting and boiling points are two common characteristic properties. Some substances like carbon dioxide on this table, carbon dioxide or citric acid, those guys are a little bit strange when you look here. Carbon dioxide doesn't actually melt, and therefore it doesn't boil. Carbon dioxide at minus 78 degrees Celsius sublimes, so it turns from a solid directly to a gas. Citric acid, potassium nitrate, sodium nitrate, those are all solid substances at room temperature, and they have melting points. But when they've melted and turned to liquids, if you continue to heat them, the liquids don't boil. Instead, they chemically break down, they decompose. So those substances don't actually have boiling points. But most substances in the list have a melting point and have a boiling point, which would help you identify those substances if you were given an unknown sample to work with. So melting point, boiling points, and densities, three very common characteristic properties.